In this video we are going to see exercises of runway length starting from the data of an aircraft, to obtain the length of runway which that aircraft needs to land in given conditions. For that, we go to this book of Excel and here we say that we want to know, using the data in the manual for the design of aerodromes, runways and without taking into account the clause which limits the total altitude correction and temperature, determining the runway necessary to take off the following aircraft. A Boeing 767-300 extended range. What does this mean? It means that we are going to take the data from the manual for the design of aerodromes, runways, in the aircraft annex, although they are not the most accurate, so that we have all the same data, and if the correction obtained is more than 35%, in the correction composed by altitude, temperature and slope, then we are going to apply it likewise. Well, this is to take off. That is why we have here the manual for the design of aerodromes, runways. We're going to put up here 7, 6 and 7. And here we have the 767-300 extended range, has 2,540 meters as length of field of reference, according to this manual. Then we are going to put 2,540. We have an altitude of pressure of 682 meters, a reference temperature aerodrome of 12 degrees and a runway slope of 0.20. In this case, it is expressed as percentage. Please note that we don't have the percent. It is here, with which we assume that it is a percentage, and it is not expressed as a fraction of 1. If here it said 0.20 times 100, although we would see 0.20, this is 0.0020 in reality. Well, the length of field of reference is this. We estimate the difference of temperature we estimate the temperature ESA at that altitude, which is 15 minus 6.5 times B7, which is the altitude, divided by 1,000. Because they are 6.5 degrees less per each 1,000 meters, we estimate the temperature correction which is a 1% of the difference of the aerodrome reference temperature with this temperature. In this case, it is a 1.4%. This is expressed over 1. Then we estimate the correction of altitude, which is a 7% for every 300 meters. Then we divide 682 by 300. We multiply by 0 minutes 7 seconds and we get a 15.91%. And the slope correction, which we see that we have here a condition, if the length of reference field is higher than 900 meters, we apply the slope correction, not if that condition is not fulfilled. And the slope correction is a 10% for each 1%. As it is expressed in percentage, we multiply it by 0.1. Please note that it says that if this is higher than 900 is this, and is 0 in the other case. Well, let's join the total correction. It is to add these three, and in this case, as we have the length of the reference field, and we want to know the length of the runway under real conditions, what we do is multiplying by 1 plus the corrections, resulting in more or less 3,000. We are going to remove the decimals. I was wrong. It is 3,031 meters. 3,031 meters. We are going to see the same thing for an A320. For an A320 in Valencia. The data of Valencia has been obtained from the APE Spain, okay? Then this would be 31 degrees. This is the APE Spain. We have sought APE España. We have clicked and here we have 73 meters, 31 degrees Celsius and here below the reference field length. The length available, which are 3,215 meters and the slopes, which is the highest altitude minus the lowest altitude. In this case it is the latter, but could be in the middle, divided by the length of the runway. Then we have here data from the runway. And now we are going to, first of all we are going to aerodrome, runways reference manual, the annex that it has, where it has data from aircraft and here we are going to look for A320s. Then we see that we have from the A320-200, we are going to work with these, okay? There is only one. They are 2,480 meters. We put it here. We estimate the temperature ESA to 73 meters, which are 15 minus 6.5 degrees times 73 divided by 1,000. Then we estimate the correction. We estimate the correction for temperature, which is a 1% for each degree of difference between the temperature of reference of the aerodrome and this temperature, which is this subtraction, which leaves us 16.47 at NVSP. Then the correction for the altitude will be very little. There is a 1.7%, because it is 73 divided by 300 times 0.7, because it is a 7% for every 300 meters. The correction by slope, in this case is expressed in times 1, because although here it puts 0.64, it has the percent in here, and this it means that if we put in normal numeric format you will see that it is 0.0064. What happens is that Excel puts it in this way. What does that mean? That, If we have this in terms of times 1, it had to be multiplied by 100 because the correction is a 10% for each percent of slope. Do you agree? We have again the same condition that if the length of field of reference is more than 900 meters we apply it, and if not, no. Joining all corrections together and multiplying by 1 plus this correction to find the length that we would require with standard formulas. It would need 3090, so you can land, but it is that if we have the manual of aerodromes planning of this aircraft, okay? You can search it like Airport Planning Manual A320, we would have a more accurate data that allows us to calculate this better. I have here the Airport Planning A320 manual, okay? In the page 58 we have the weights. We are going to work with this version. It is not exactly comparable, but is more or less A320 with this configuration, which has a maximum takeoff weight of 73,500 kilograms or 162,000 pounds. Then we have to seek in this manual, which I have already sought the pages and graphs. They are in the page 185 and give us some graphics for temperature in ESA conditions, for a type of engine CFM56 and for another type of engine ZAE V2500. We are going to assume that we have CFM56. Under what conditions are we? Well, here we can really subtract from the temperature. You know, this is the difference between the temperature that we have and the temperature ESA at that altitude, which are 16.47, do you agree? Falls within the tolerances allowed using a graphic until a trifle above the temperature for which is calculated, do you agree? Then we can use the ESA plus 15. We are going to ESA plus 15, which would be this. We have said that our aircraft will have CFM56 engines, it would be this. Then we are going to 160,000 pounds, more or less, which is here, and we are going to the 0 curve feet. This is 0 feet, 200, 400 feet in reality. It would be a little bit beyond the curve of 0 feet because we have 73 feet. We descend here and comes, more or less, 1750, 1800 meters length that the airplane needs for genuinely take off in these conditions. If you're going to put 1,800 meters, as you know it is rather less than what the standard corrections say. Why? Probably because these tables are made a long time ago. And then the aircraft has now quite more power. In addition, the other are standard corrections. With what we have worked, are the accurate data of this category of aircraft. Obviously, the pilot each time has to do these calculations, must go to the handbook of the aircraft, which is now in an iPad, but it has to work with the exact details of his plane. These are generic data to plan airports, but each pilot has the manual of its aircraft, in this case, now in its iPad. You have seen they have an app for calculation, but what really do is to translating these data for the pilot to know the conditions to take off in such conditions exactly. Well, we are going to see a final exercise, which is how needs a 747-400 in Valencia to take off. The data we have exactly the same here, okay? Let's say 31 degrees. Well, if we go here, and with CRTL plus F, 747. I have the 747-400, which are 2,890 meters. The calculations are exactly the same, okay? Because the difference with the ESA, the temperature correction, by altitude and by slope, which will not be the same total correction and results in 3,601 meters, which implies that a 747 is not. The design of the Valencia airport is not for a 747. It can land. Why? Because it is not always such a hot day, which, with it is calculated the aerodrome reference temperature that is the average of the maximum of the warmest month, okay? Then, if instead of 30 degrees, made 16, it could enter into Valencia with maximum takeoff weight, or it could enter with more temperature, but not with that maximum takeoff weight. Well, I will conclude with this video on which we have seen the application the corrections of runway length, taking the data on airplane and obtaining the runway which really needed for land in conditions given.